is how to design this diagram using the given expression. Okay, here we use 8 by 1 marks, and here also we use 8 by 1 marks to to um, to express this sum and the carry out. Now here what we're going to see is, let's say the question is asking use 4 by 1 marks only. Use 4 by 1 marks, and also use only one. Use only one. And here also use 4 by 1 marks. Only one. Okay. So let's see how to design this. First, I'm going to grab this question and put it in another page so we can do it over there. Okay, now we have this question. Now let's go ahead and design this one. So first, to draw this one, we have to write the truth table. We have 3 variables, so it's going to be 8 different alignment, because 2 power 3, 8 different alignment. For A, B, and then the C, and then we are going to have one for the sum and one for the carry out. Okay, here we go. Better to divide by 8 as well, so we won't mess up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's see. So first, what we are going to have, we are going to have A, B, C variables. These are control signals actually, A, B, C control signals. And then we are going to have the sum and the carry out. So since we have 3 variables, it's going to be 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 0, 0, 1, 1, 1, 1. Okay, so these are the 8 different alignment, and here we have this expression given in terms of min term. Min term mean at this location these values this is going to be 1. So let's look at for sum. For sum, this is 1 at 1 right here, 1 at 2 as well, 2 is right here, and 1 at 4 is right here, and then 1 at 7, that's right here, and the others are going to be 0. Better to write this one into, let's write different color. The others are going to be 0. Let's look at the carry out. Carry out is 1 at 3, so 3 is right here, and then 1 at 5, 5 is right here, and then 1 at 6, that's right here, and then 1 at 7, that's right here. Okay, so what we're going to do is we are going to design the sum and carry out with 4 by 1 marks. Let's use the marks right now. Let me use a different color. Okay. This is one of our 4 by 1 marks. Okay, and we have 2 control signals. One is A and the other one is B. The output is going to be the sum, and this is 4 by 1 marks. So we are going to have 4 inputs. Okay, how to determine the inputs? That's basically what you have to see. So to determine the marks, to determine the values we are going to put, you can see I took 2 of them, right? If you look at my last one, I took 3 control signals, but for this one I took 2 of them because I'm going to put the C as the input. Now to do the C as the input, we had to compare. We had to compare that when C is equal to certain value, what happening to the sum value. So we had to compare them, and then make the decision what to put. So that's why we group them. Like why I took AB, I can take BC as well. You know, you can take BC, you can take AC and put the B here. You can do anything you want. But the thing is, if you take BC, the grouping is going to be a little bit hard. Like here, as I do, you can see like it's better to explain after I done so you can clearly see it. So let's see what's going to be the value for the C we are going to have. So first compare this one. When A and B are 0, 0. When A and B are 0, 0, these two column. Let me use a different color for this, so I don't. Okay, if I look at these two diagram, this is the diagram when A and B is 0, 0. What happened to the C when C is 0? What happened to the S? When C is 1, what happened to S? So here you can see when C is 0, S is also 0. When C is 1, S is also 1. So it means whatever the value C have, that's going to be the value for S as well. So I can just put C right here. C is my input when 0, 0. Now let's compare when A is 0, B is 1. You see, that's why easier to group. If you take A, B, it's easier to group like this. But if you take B, C, then I have 0, 0 right here and the other 0, 0 right here. So I have to look both of them carefully, right? You can do that too. It works. But the thing is, you have to. It's a lot like you have to look carefully and find out the relations. This one is easier to see. Now let's look at this one. When okay, I didn't put this one yet. So when A and B are 0, 1, 0, 1, what happening to the C? When C is 0, S is 1. When C is 1, S is 0. So this is opposite relationship. So this is C naught. Okay. Let's look at the next one. Let's group these two. When A is 1, B is 0. When A is 1, B is 0. So here, let's look at the C. C is 0 and S is 1. When C is 0, S is 1. When C is 1, S is 0. So it is opposite relationship. So we put a C bar for this one as well. Let's group these two. When A and B are 1, 1, what happened into the C? When C is 0, S is also 0. When C is 1, S is also 1. So it means this is C. Okay, that's going to be the 4 by 1 max expression for this sum table. Like you don't, if you want to do by 4 by 1, you don't have to go and do all these things. This is what we did in my last video. You don't have to do that. You can do like this as well. Let's look at the other one. We have the carry out as well. Let's design that one. So for that one also, the question is asking us to use only 4 by 1 marks. So we are using the 4 by 1 marks, and we have 4 inputs like this, and we have 2 control signals. One is A and the other one is B, and the output is going to be C out. Okay, let's decide. When A and B are 0, 0, what's happening to the C? Here we have to combine these two. We have to compare these two, C and C out. Okay, we don't care about what happening to S. So when C is 0, C out is what? When C is 0, C out also 0. When C is 1, C out is still 0. So it doesn't matter what is C value, the C out is always going to be 0. So what you can do is you can connect this one with the ground, because the value is always 0. Doesn't matter what you put for C. So we can connect this one to the ground, and then let's look at the next two. 0, 1, 0, 1. When A is 0, 1, B is 0, 1. I mean A is 0, B is 1. Let's look at the C. C is 0. When C is 0, C out is 0. When C is 1, C out also 1. So it means this is a C. Let's look at this group. When A is 1 and B is 0. So here when C is 0, C out also 0. When C is 1, C out also 1. So this is a C. Let's look at this 1, 1 group. When A is 1, B is 1. what's happening to C and C out. When C is 0, C out is 1. When C is 1, C out is still 1. So it doesn't matter what do you put for C, the C out is always going to be 1. So what you do, 1 mean you connect this one with VCC. And that's it. That's our diagram. And this one is B. This is a control system, A and B. And that's basically it. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.